Hello everyone. The title of this video is Determine whether a function is one-to-one. Now each example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. I'm in their Algebra and Trigonometry text and in section 3.1 titled Functions and Function Notation. And I'm under the heading Determining whether a function is one-to-one. Actually, I'm only going to be doing a couple examples, and they're actually the two of the try it problems in this reading, because this is just a brief introduction to one-to-one functions. We'll get into much more detail and practice much more, with one-to-one functions, finding if functions are one-to-one or not in later videos as well. So in my first example, I just wrote down, let's do try it problem number 9 from the text. Right? But before I get to that, I want to talk about, the definition. Right? A definition. A function is one-to-one if each output is paired with exactly one input. So if each value in the range is paired with or corresponds to exactly one value and no more than one value in the domain. So if each output, right, value in the range, is paired with exactly one that's huge right there. Exactly one input. Alright, so first off, it's a function. Remember the definition of function was every input is paired with exactly one output. And then to make a function special and make it one-to-one, you have the other relationship as well. It goes the other way around. Not only is every input paired with one output, but every output is paired to one input. Right? Thus the name one-to-one. Right? One input to one output and one output to one input. Right? Goes both directions. Alright, so for example, I'll just draw some swift little pictures here. So suppose here's the domain. I'll just draw some little arrow diagrams, little mappings. So say this is the domain and this is the range. And, here's a couple elements of the domain. Here's a couple elements of the range. If, this element mapped that way, this element mapped to that element, and this element corresponds or pairs with that element, this would be an example of a one-to-one function. Alright, this would be an example of a one-to-one function, right? First off, it's a function, right? Every domain element has just one arrow coming off of it. But it's also one-to-one because every range element only has one arrow going into it. Right? There's no range element with more than one arrow going into it. Another thing about one-to-one that you could say is if you were to reverse the mapping, it would still be a function. You know, the reverse mapping would also be a function. Right? If I were to reverse these arrows, right? If I were to go from, you know, take this and go this way and this and go this way, right? It would still be a function, right? These range elements correspond to exactly one domain element, right? And it's still a function. Right? Now another example with a Swift picture and just a domain and range. Now here's a function. Okay, again, I got two elements here. It's still a function. You know, each element in the domain corresponds to one element of the range, right? That element, and this element of the domain corresponds to that element of the range. There's only one arrow coming off. So this is a function, but this is not one-to-one. Because of this element here, right? There's an element and there's an output that's paired with more than one input, right? There's more than one arrow going into this element of the range here. Right? And another way you can think about this is if you were to reverse these arrows, the reverse would not be a function. I'll just say the reverse would not be a function. And that's a way you can test, you know, if you have a one-to-one function or not. You look at the function, then you say, oh, what if I reverse this? Would the reverse also be a function? If the reverse would also be a function, that means your original function is one-to-one. If the reverse would not be a function, right, watch this, right, I would have this element corresponding to that, you know, just reversing the arrows. And you see, whoa, this element here goes to two different outputs, you know, if I reverse it. That can't happen in a function, right? The reverse is not a function. If the reverse was not a function, that means the original function is not one-to-one, right? So and I hope the concept's simple. It's one input to one output to one input. All right. So in these examples here, I'll draw some pictures, but let's look at try it number 9 from the text. All right, so I'm going to go back to the OpenStax text. Now you can read through, you can read through the stuff here, the definition, do the examples on your own. All right. So try it number 9 has 3 parts. All right, so part A is a balance a function of the bank account number. All right, so let's think about that. Now they're talking about bank accounts, right? Balance is how much money you have in the account, right? So let me write this out. So they're asking, again, is balance a function of the account number? Now I've brought this up in previous videos on, you know, determining if a relation is a function or not. When they say balance is a function of account number, the bank account number, that means, you know, does each account number, right, correspond to exactly one balance? Now think about that, right? So say I have like account numbers over here, right? And then, you know, balances over here. Now I'm just going to do some simple numbers. I know usually account numbers have many digits. I'm just say account number 1, and you go to person number 1's account number 1, and they have $100 in there. All right, so there's one correspondence. Right. And that's it, right? Each account number will have just one balance, right? You don't open up your account and say, oh, I've got $100 and $300 in there, right? Yeah, each account has one balance, right? Account number 2, say, has 500 bucks in it. So I mean, the answer is yes, right? That should make sense to you. Yes, balance is a function of account number. Balance is a function of account number. Now, I'm just making these numbers up right now, but when you go to a particular account number, there should just be one number there for the balance, right? One balance for each account number. So yes, right, balance is a function of account number. Now, part B is the other way around. Now, can't I have two account numbers with the same balance, though? Couldn't account number 3 also have $500 in it? That's possible, right? That's possible. Two different accounts can have the same amount of money. So yeah, I have a function, right, from account numbers to balance. Balance is a function of account number. But what if I reverse that? Right. So that's what question B is, right? Part B is bank account number, right? So is account number, two C's, sorry. Is account number a function of the balance? So reverse this, right? So does each balance get paired with exactly one account number? No. All right, the answer is no to this one. Watch, right? Because I could just reverse the mapping from the previous picture, balance and then account number, right? And we had balances of $100. Again, I just made these up. You can make your own up if you want, but I had accounts with balances of $100 and $500. There was account 1, account 2, account 3, and the $100 balance that was account 1. And then the 500, there were two $500 balances, right? Account 2 had a $500 balance, and account 3 had a $500 balance. That can happen, right? Multiple accounts can have the same amount of money in them. So, not a function. Account number is not a function of balance. Right? Account number, I'll just abbreviate it this way, is not a function of balance. And I said this on the first page, if you reverse the mapping, if you reverse it and it's not a function, if you take a function, reverse it, and it's not a function, then the original function you were looking at is not a one-to-one function. All right, so balance is a function of account number, but account number is not a function of balance. This means that balance is not a one-to-one function of account number, right? Because again, there are balances that can have two account numbers with that same balance, or three account numbers with that same balance, more than one, right? So every input, every account number goes to one balance, but not the other way around, right? Every balance doesn't necessarily go to one account number. It could go to more. So in part C, right, we would just say, so balance is not a one-to-one function of account number. All right. So it's a balance is a function of an account number, right? Each account number goes to one balance, but it's not a one-to-one function of account number because you can't reverse it, right? Reversing it is not a function. So each account number goes to one balance, but not the other way around. Right, so not one-to-one. I hope that makes sense. I know it's a lot of words here, but that's the idea. Right? That's the idea. One-to-one, one input to one output to one input, right? It goes both ways. Great. All right, then try it. My next example. Let's do this. Next example 2 is just try it problem number 10 from the text. Right, so let's go back to the text. All right, and try it number 10. So evaluate the following. There's again part A, part B. If each percent grade earned in a course translates to one letter grade, is letter grade a function of percent grade? Yes. All right, again, let me draw this out. Okay, so this is again the question here is letter grade a function of percent grade? That means, does each percent grade correspond to exactly one letter grade? Now let's think about that, right? So again, the domain here would be percentages, right? And the range will be letter. Right? Now the letter grades, are A, B, C, D, and I know there's pluses and stuff. I'm just going A, B, C, D, E, and F, right? Usually. And percentages, now there's all sorts of percentages, 1 to 100. But if I got 100%, that would correspond to an A, right? And nothing else, right? You're not going to get 100% and get an A and a B. 99% would also correspond to an A, and that's it, right? 99%, you're not going to get an A and a B. And so on, and say 85% would correspond to a B. Right, and that's it though, right? That's it. A 62% probably be a D, and whatever, right? Now, this is a function, right? This is a function because every single value of input, every single domain value, every single percentage goes to exactly one output, exactly one letter, not multiple letters at the same time. So yes, right? Yes, letter grade is a function of percent grade. Right. All right, so now that we know letter grade is a function of percent grade, the next logical question would be the question they ask. Well, is this function, right, is letter grade a one-to-one function of percent grade, right? Is this function that we're seeing here one-to-one? The answer is no. Right, the answer is no again. Look at, if I reversed this, if I asked the other question, if I said, is percent grade a function of letter grade, the answer would be no. Because A corresponds to 100, 99, 98, 97, right? B corresponds to 85, 84, 83, 87, 88. C corresponds to 70, 71, 72, right, usually. So, no. right? No, the function's not one-to-one. Each letter grade corresponds to more than 1% grade. Not exactly one. Right? And that's why. And you don't even have to say every letter grade. Just say A. Just find one letter grade that corresponds to more than 1% grade, and there it's not one-to-one. Right? In order for a function to be one-to-one, every input goes to exactly one output, and every output corresponds to exactly one input, not more. All right, so these two examples I showed you here, they're not one-to-one functions. Like I said, you can go back and read through the thing yourself. Like, example 13 gives you an example of a function that is one-to-one. Right? The area is the area of a circle a function of its radius. Yeah, each radius will give you one area. And if you know the area, you know the radius, right? If you know each radius gives you an area, each area gives you a radius, that's a one-to-one function. Yeah, and read through this example here. The letter grade to grade point average, that would be a one-to-one function. Right? Each letter grade gives me a grade point average. Each grade point average tells me the letter grade. Right? It's one-to-one. So you can read through this on your own. Right? But just know that that's a very brief introduction to one-to-oneness, and we'll get much more into it later when we talk about like the horizontal line test for functions and stuff like that. Right? All right, so I'm hoping that watching me do these couple examples here gives you a decent introduction and helps you out a little bit when you're talking about determining if a function is one-to-one or not. Right? Just understand the definition. And thank you very much for watching.